Again, this is the back page of assignment 832 from Tuesday's folder. Okay, 8-20, 120. All right, so now you got to multiply this twice. I can multiply these two together, both complex parts, or I could do the real part and a complex part, which would be a 2x3 box. I'm going to start with the hardest part and then do the easier part next. So I'm going to do a 3x3 box. So that means I would set up x plus 2, 5i, x plus 2, and negative 5i. Once I multiply all that out, in this case, I'll still have x plus 1. I'm going to end up with 3 terms here because when you multiply complex numbers, a lot of stuff cancels out, okay? Most of it cancels out. Then after that, I'm going to have to multiply and set up a 2x3 box to simplify the rest. All right. And then I'll have my final fully standard equation. Okay. So again, the key part is that beginning part is that change the real part of the complex number or solution, switch the sign, and then 3x3 and 2x3. Okay, now the part 2, I'm sorry, not part 2. The next question, 8-121. It says use the remainder theorem to determine P of 2. I don't know if you guys remember when we worked with problems like back in quarter 2, when it said P of or F of some number, you took that number and you just plugged it in, right? You plugged in the input and then you found the output. This is the same question. It's saying plug in 2 and figure out the output. The remainder theorem just means I can use synthetic division to do the same thing. So instead of like, as opposed to setting it up like this, where I do, let's say, I actually plug it into every term. So this is that same question, right? So as opposed to doing that and plugging in every term and then simplifying, I can use synthetic division to do the same thing, okay? And what you end up with right here is the output. So this, I put R, this is also the output that you end up with. Now, if the output is 0, not only is that the output, that also tells you that 2 is a factor, okay? And that was that second question, part of the question that I told you guys to cross out, which it just kind of like, this all ties together, okay? So I'm going to tell you, you're going to end up with 0, okay? So you already know that x minus 2 is a factor because we plugged into 2, so that means the factor is x minus 2. What you get from right here on the bottom, that's going to be the answer to question C. Because it says use your answer from B or from A right now to determine the other factor. So whatever you end up with here, that's your other factor. Okay, which is going to be 3 terms. In order to, and then the next question is, what are all the solutions? Well, to figure out all the solutions, and if you have 3 terms, and you start with x squared, some other number in here, what do I have to use to figure out the rest of the roots? This is going to be x squared. I'll tell you that right now. And then there'll be 2 more terms after that. So what method do we use to solve that type of equation? Quadratic formula. So basically, here, I'm going to use the quadratic formula on that factor to figure out the last 2 solutions, okay? So use the quadratic formula in the last step. You already know one solution. What is one solution based on all that you see here? 2. So you already have x equals 2. You got to find the last 2. Okay, the bottom says given the equation 5x squared plus bx, notice there's no number there, plus 20 equals 0. For what values of b does this equation have real solutions? In other words, it's asking what numbers could I put there for b to end up with a real number, not some like imaginary number like that. Okay. The way you want to approach this is think about quadratic formula. Okay. If I'm doing the quadratic formula, I'm going to write that down here at the bottom. So negative b plus and minus the square root of b squared minus 4ac. As I'm working on this problem, when do I know, or what part of this will tell me I'm going to have a complex or imaginary number? What part of this tells me that? The what? The -4, more specifically, the square root part. What do I usually end up with in the square root when I have a complex or imaginary number? What kind of number is usually in there? Like after I do b squared, then -4, and then times a and c, and then subtract, what kind of number do I usually have in there if it ends up with an I? A negative. So really all we have to do to figure out what values for b would make a real number is to figure out what numbers would I plug in here to make that less than 0. Okay. So this part of that, just the part inside that square root, it has a name. It's called the discriminant. Maybe you remember that from last year or IM-1, maybe yes or no. Maybe the word sounds familiar, but just that part on the inside is called the discriminant. So basically we want to know what value of b is going to make that less than 0. Okay. So here's how we set that up. Actually, we want to know what values make it bigger than 0 because we want them to be real. We want them to be positive. So my equation I'm going to set up is just that part, b squared minus 4 times ac. I want to know when will that be greater than or equal to 0. Okay, so we don't know b, so we leave that alone, but we know a and c. So 4 times the a is 5, the c is 20. If I multiply 4 times 5, that's 20 times 20 again. That's 400. Okay, now if you guys notice, it's inequality. So it's going to be solved slightly different at the end here. So I'm going to add 400 to both sides. I end up with b squared is greater than or equal to 400. How do I solve square roots? What will be the next step? Or sorry, not square roots, squares. How do we solve b squared? Square root. Got to do the opposite of the inverse. So I square root both sides. I get b squared, b here, and 20 here. Now, if you guys remember, when you square root, you end up with how many solutions? 2. Okay, now here's the deal with this one. It's not plus or minus 20. Okay, because when you're dealing with the inequality, it's a little bit different. All right, when you're dealing with the inequality, I have to think, let's say I go back to just this step right here. If I plugged in 20 squared is 400, right? But if I plug in -20, well, that's also 400 because -20 times -20. So what I'm going to do here is say the absolute value of b has to be greater than or equal to 20. Okay. So as long as that number is bigger than 20, or it's equal to 20 or bigger, it's going to give you a real solution, because that's the goal here, is I want this to be greater than or equal to 0. So to finish this, I split this into 2. If you guys remember inequalities, the first one would be b is greater than 20. You just always write the same. The second one changes. The 20 becomes negative, but you also switch the sign. So now it's less than or equal to 20, which makes sense because when you think about it, if I did a number like a smaller negative, let's say like negative 10. Negative 10 squared back here is not greater than 400. So I want a bigger negative. That's why we want to go less than negative 20. Okay, so that would be the answer there. So I'm just giving you guys that one basically, because I knew that we didn't really do too much with squared types of inequalities. So that's a gimme. Okay, now the next question, logs. Now with the logs, it's asking you to take these two and combine them into one. But before you do that, we need to get rid of this 8 and this 9. What can I do with the 8 to get rid of it so it's not in front of the log? Where can I move it to? The what? So you have the product rule, which allows you to combine two logs together when you add. You have the quotient rule, which also lets you combine them. But the other one is called the power rule. The power rule says that if I get a number in the front, I can basically take it, move it to the exponent of whatever that number is in the log. So now what this becomes is log base 3 of y to the 8th power. So now it just becomes the exponent. Now I can combine both of these a's. I can combine y to the 8th and 2x. Now when you add two logs, how do you combine those, the a values? Do you multiply them or divide them? When you're adding, multiply, right? So you're going to combine this into one log by multiplying the a's, okay? On the next one, I do the same thing. Sorry, I'm running out of room. Wish I could write tinier, but I wish there was more room on here. I'm going to move that 9 into the exponent. So now this will become what? Log base 4 of what would that be? N to the power 9. Oops. Now, on the next step, I can combine them into one. But how do I combine these two logs in this case? By divide, by division. Okay, so now which of these goes on top? The 5m or the n over n to the 9? Right, the first one. Okay, so now you can combine those two together. Okay, again, that was from yesterday. All right, so we'll finish with some notes that'll help you guys out with today's topic, which is shifting gears. This is all about polynomials and roots and zeros. Now we're switching to triangles or trigonometry. Okay, so now you should be in your notebook. You guys should have that written down. Okay, we're looking for the missing sides. Now, these are called special right triangles because they have a special relationship because of the size of the angles. When you have a triangle that has a 90-degree angle, a 60-degree angle, that third angle will be what? Yep, be 30. So basically it's called a 30, 60, 90 triangle. All right, the ratio that these have is the side that is across from 30 has a ratio of 1. The one that's across from 60 has a ratio of square root of 3. And the ratio across from 90 is 2. What does that mean? Well, basically what it means, first of all, this for this triangle, which one is across from 30? Y. You look at the angle and then look straight across, or the opposite side of that angle. That's the one that's associated with that. And then which one is across from 90? X. So what this ratio means is that the one across from, basically X in this case, is twice as big as Y. Because if it's a 1-to-2 ratio, that means one is double the size of the other. Okay. If something was like a 1-to-4 ratio, that means something is 4 times the size of the other. Okay. Or vice versa. If it was like, or you could say that Y is twice as small. Okay. So that's what the ratio means. All right. It's how they relate in size. All right. So when I set this up, I'm going to set up my ratio next to the triangle. One rad 3, and then 2. And then what I want to do is I need to write the side that's across from 30, which in this case is Y. Then the side across from 60, which is 2. And then across from 90 is X. I'm going to just highlight those. Okay. Just to kind of show how these all relate. Okay. All right. So now what I'm doing is I'm using these ratios. These ratios basically create what's called a proportion when you have one value over another. And I can use that to create an equation. All right. So what I need first is I need a ratio that's known. In other words, a pair, a complete pair. I don't know if you guys remember law of sines. It's been a while. But law of sines, you had to have a pair where you didn't have like a variable, basically. So I'm going to take that known pair, and then either the 2 over x or the 1 over y. I can start with either one. Okay, so I'm going to start with these two on the left, these two pairs here, and then make an equation to solve for y. So first 1 over y, and make that equal to rad 3 over 2. Now we just solve that. Now, the two examples I'm going to show you are some of the harder examples. I did that on purpose because Miss Menard's are some of the easier ones. So I'm focusing on the more of the harder examples here. All right, so here, cross multiply. So y times radical 3, or square root of 3, and then 1 times 2. Now we're getting y by itself, so divide both sides by square root of 3. Now the only thing is that the rule is when it comes to writing out solutions or values is you don't want to have a square root in your denominator. Okay, so no radicals in general, no radicals in the denominator. So what we can do to get rid of that is what's called rationalize. We're going to rationalize this. Okay, so before we do that and show you how to do it, I'm going to show you what happens with square roots. So if I take the square root of 2 and I multiply it times the square root of 2, you guys know what that's equal to? What's the square root of 2 times square root of 2? And what's the square root of 4? Equal to. 2. All right, so if I take the square root of 3 times the square root of 3, what's that equal to? 3. Square root of 5 times the square root of 5 is equal to what? Kind of getting the idea here? If I multiply the same square root twice, or same radical, it could be like a cube root, a fourth root, as long as it's the same thing twice, it's just equal to the number inside. Okay? Actually, it's different with cube roots and fourth roots, but we're not dealing with those right now. Okay? So what I need to do is get rid of that square root, right? So what I can do is now multiply the top and the bottom by square root of 3. So now, first of all, this cancels out on the left because it's just square root of 3 divided by square root of 3. And then here, the top is going to be 2 times square root of 3. The bottom is square root of 3 times square root of 3, which we see is just 3. So now you have an exact value for y without a radical in the bottom. Okay, now we do the same thing with the other side. Now we're going to do the same thing for x. Now what we're going to do is take these two pairs, rad 3 over 2 and 2 over x, and create an equation with that. So rad 3 over 2 equal to 2 over x. Kind of similar steps. Now x times radical 3 and 2 times 2, 4. And now the steps are pretty much the same after that. You divide by 3, and then you've got another radical in the bottom. So now we multiply that on the top and bottom of the fraction. And it put 4 times the radical 3. And then again, we're multiplying 2 square roots. So we just end up with 3 itself. Okay, now just know that most of your problems aren't going to be like that. I was, again, just picking out the harder ones. Most of the problems you're going to have, you won't have to rationalize at the end. You're not going to have to do this extra step. You're just going to, once you cross multiply and divide, you're done. Okay, you'll have your answer. Now you want to do check like between the number on the outside of the square root and the one on the bottom, see if they reduce. Like if it was like 4 over 6, you divide them. Okay, so try to reduce it if you can. All right, so one more. And on this triangle, we're going to look at not a 30, 60, 90, but a 45, 45, 90. All right, so this one is very similar. So first of all, this will be, we'll call this x, this is y, and this is 9. Now, the one thing you need to know about a 45, 45, 90 is that if the angles are the same, that means those sides will be the same as well. So once I find x, I already have y because they're the same thing. So basically, I only have to do one step. I just got to find one or the other. Okay, so I'm going to set up my ratio. And the ratio for 45, 40 of 90 is 1 to 1 for the 45-degree sides. Because that makes sense, right? They're the same angle, so they should be 1 to 1. But the last one is 1 to rad 2, or square root of 2. Okay, now the way you set it up is the exact same as the other. You just got to remember the difference in the ratio, okay? So now the one that's across from 45 is both x and y. So I can put that here and here. And the one that's across from the 90 is the 9. Now, just like before, I need to start with the pair that's complete. So these two. What I'll do is basically take these two pairs here and create the equation. So 1 over y, and then rad 2 over 9, cross multiply. So now I have y rad 2 times rad 2, or square root of 2, equals 1 times 9. And now Again, divide, just like before. And as you can see, here's another problem where you have to rationalize because the square root's on the bottom. So I'll multiply rad 2 times rad 2 on the top and the bottom. And you end up with, now remember, once I get y, that's also equal to x. So what I'm going to do is just write x and y equals, first 9 times radical 2. That was the top part of it. And the bottom part is just 2. Again, most of these, you're not going to have to do all that, but I just wanted to show you guys the ones that are going to be a little different. Okay, and always check, is 9 over 2, can I reduce that? No. Don't reduce with the number inside the square root. That doesn't change when you reduce. Only work with the ones on the outside, okay? All right, you guys at home, that's it. That's all I got. Otherwise, I'll see y'all tomorrow. Unless you need anything else. Yep, go ahead. All right, you guys in here, what I want you guys to work on is let's get done the first 6 problems on that page of your packet. This one right here. So 9.1, let's finish those. And then after you do the 6, you can finish that or work on whatever assignment you need for class.